Okay, so we're going to start out talking about the Pythagorean theorem, practice saying that, Pythagorean, with a little bit of vocab just to make sure that you remember all your vocab terms. So a right triangle, first of all, is a triangle with one right angle, and I've circled that right angle there for you. That little box in the corner, remember, that means 90 degrees. Make sure that you're pausing the video if you need time to write down the definitions, you need a little more time on anything. And also you're going to want some colored pencils here in a second, or marker, something with color for the next activity that we're going to do. A hypotenuse, so practice that one, hypotenuse, it's the longest side of the triangle. And in this case, it's the one across from the 90-degree angle. There's my hypotenuse. So this angle right here opens up to this hypotenuse. The legs are the two shorter sides of the triangle, so they're the ones that make up the 90-degree angle in this triangle. And then a theorem is a rule in algebra expressed by symbols or a formula, and it is always true. Okay, so let's look over right now. Get your colored pencils, pause it if you need them, get some kind of color, and we're going to do an activity with this right here. Okay, so we have our triangle right here, and you might be able to see there's an A, a B, and a C. And what we've done is we've extended each side to make a square. So we have A times A, that's A squared for this square, if I was going to find the area of it. Length times width, A times A squared. B times B is B squared. C times C is C squared. That's the area of those squares. So what I'm going to do right now is I'm going to just X off how many squares I have here for A, and there are 9. So I'm going to X off 9 squares over here in C. You may wonder why we're doing that. You'll see very shortly. Okay, now I'm going to have this be B squared. I'm going to put some purple dots in all of the B squared boxes. How many are there? There are 16, right? A 4 by 4. So count out here. 7, 8, 9, 10, 11, 12, 13, 14. Okay. And 3 of these guys, there should be 16. 3 of these guys should have been X's. There we go. All right. So we have our 9 from our A squared and our 16 from our purple dots here, our B squared, and they make up C squared. So what we're proving here is for any right triangle, the length of one leg squared plus the length of the other leg squared equals the length of the hypotenuse squared. So what we just proved was A squared plus B squared equaled C squared. This side squared, this side squared equaled the big one. A squared plus B squared equals C squared. Okay, so let's look at the next page. So if we have the formula, the Pythagorean theorem of A squared plus B squared equals C squared, how would we solve for just a C, because it's got a square there? So first of all, we're going to write out the Pythagorean theorem. Write out the Pythagorean theorem, okay? So then we have the length of A, it's going to be squared, plus the length of B, it's going to be squared, equals C squared. So what you need to do is you need to plug in the length of A. Next, plug in the length of B. And then add the two squared lengths together. And then your final step, what's this guy? That's a square root. So you're going to take the square root. And it's always going to be positive, the positive square root, because we're dealing with length. You can't have a negative length. So let's look at the example next to you here. First of all, we do have a right triangle. It does not matter which one's A and which one's B, so I'll just make 8A and 6B. I'm going to write out the Pythagorean theorem. That was step 1. A squared plus B squared equals C squared. What does C have to be? It's the hypotenuse, right? The length of the longest side. So A squared, so 8 squared plus B squared, which is 6 squared, equals C squared. 8 squared is 64, 6 squared is 36. Add them together, and it's 100. Now, I don't want to know what c squared is. I want to know what c is. So I take the square root, because c times c is c squared. Whatever you do on one side, you do to the other. And 10 times 10 is c. 100 was a perfect square. So the length of that side is 10. And we would include our units if they gave them feet, inches, centimeters, whatever. Okay, so what you're going to do right now is you're going to do the same thing over here on your own. Pause the video and then come back and see how you did. All right, so if you made it to this step, here's where you wrote the formula. That's step 1. You need to have it. That's the Pythagorean theorem. Plug in what you know. I made A24 and B2, but you could have had it the other way. When you add them together, it's going to be 580. And then you take the square root. Now, when you did that, it didn't work out to a nice perfect number, did it? So C is approximately, and we're going to round to the nearest tenth, should have said 24.1 on your calculator. All right, nice work. Okay, now the examples down here, we're actually given the hypotenuse and we're missing a side length of one of the legs. So we do the same process. We start off with the Pythagorean theorem, and then we plug in what we know. Well, we don't know A, so we keep it as A squared. 6 is B, so that's 6 squared, and C is 9. Then solve what you can. So it's A squared plus 36 equals 81. Subtract 36 to both sides, and you're left with A squared equals 45. And now we're at the same idea over there. You take the square root of both sides. 45 is not a perfect square, so I know I'm going to need to write approximately, and it's approximately 6.7. Make sure you use your rounding rules correctly for your answer. All right, so find length of leg B in this one. Pause, and then come back and see how you did. So B ended up equaling 12. We were looking for B. We knew A was 35 because that's a leg. It makes up the right angle. The longest side was 37, so that was the hypotenuse. And then it ended up being B squared is 144. Take the square root of both sides, and B equals 12. So at this point, if you're confused, you should probably check in with Mrs. Wyman so she can help you on your notes. If you're doing all right, then we're going to move on to the next examples here. Now, clearly these are not right triangles, right? I don't see a right angle here, and that would be a rectangle. So how can we find the value of C? We have to be a little crafty and creative. We're going to make a right triangle to help us do that. Now this triangle right here looks to be isosceles. If it was isosceles, then I could drop down a right angle here and cut that in half, and that would mean, if it was isosceles, C would equal 4. Okay? Now, I could use Pythagorean theorem to help me figure that out, to find out this missing length here if I knew it was isosceles and these were the same, but I don't know any of that for sure. So we are going to say we're not positive this is isosceles, so we don't have a right triangle. So we're not sure that C is 4. However, we can for sure make a right triangle with the next guy. So let's look at the next guy. If I use my ruler here, might be a little off. There we go, pretty good. And I cut that in half. I absolutely have a right triangle, don't I? Okay. Then I could have A squared plus B squared equals C squared. But look, what did they say C was? If this is a rectangle, what's that? 13. And then I could use it to find the missing side there. So just trying to make you aware of using your rules of different shapes to find the other sides. It says find the value of C with the Pythagorean theorem. I don't even need to use the Pythagorean theorem to find it if I have a rectangle here or I have an isosceles triangle here. If you don't know the side lengths for sure, like absolutely it's a rectangle, they don't give you the key things like the right angles here, then you can't assume that it is there. Just kind of making you aware you're probably not going to have any like this, or you just at least need to identify that it's not a right triangle. Okay, so let's talk about if-then statements. So you're going to fill in some if-then statements. You're going to write your own words here. So it says, what if? If I could eat a pizza with President Obama, then, I don't know, you decide what it is. Maybe it's, I would be happy. I would make sure it had mushrooms on it. I don't know, you decide. If I owned a pet rhinoceros, then he would wreck my house. I don't know, you decide. If blank, then I would buy a new pair of sneakers. So we just made some if-then statements. An if-then statement is just like the name it describes. It's a statement that says if something is true, then something else will happen. So if P, then Q, and that's how we write it mathematically. If P, then Q. All right, so over here we have some if-then statements. The Pythagorean theorem can be written in an if-then form. So brainstorm, it says with a friend, you don't have a friend right now, but brainstorm, I'm sure you have a friend, just not one you're working with, right? Brainstorm an if-then statement. So if a triangle is a right triangle, what would you know? If a triangle is a right triangle, then a squared plus b squared equals c squared. Or you may have said, if a squared plus b squared equals c squared, then the triangle is a right triangle. That's what we know about the Pythagorean theorem. A squared plus b squared equals c squared always works for right triangles. So let's do some practice here. It says, if a triangle is a right triangle, what property must it have? Pythagorean theorem, right? A squared plus b squared equals c squared. Let me zoom in here just a second. All right, so it says I have a triangle here, and we need to prove if it's a right triangle. If it is a right triangle, we know a squared plus b squared is going to be c squared. So let's check it and see if it is. Is 3 squared plus 5 squared equal to 7 squared? So is 9 plus 25 equal to 49? Okay, well, what's 9 plus 25? 34. 34 does not equal 49, so you would say this is not a right triangle. The Pythagorean theorem doesn't work, so there's no way it can be a right triangle. Okay, go ahead and pause the video and check and see if triangle 2 is a right triangle. Okay, it worked out. 289 equals 289, so you know that this is a right triangle. You could even make a sketch of it. You'd have one side is 15, maybe inches, centimeters, millimeters. One side is 8, one side, the hypotenuse, would be 17, and you'd have a right angle across from that 17. Okay, so we are on to the next thing here. You're going to be working on the assignments that continue and follow your steps as they are specified online on my website. Great job, guys.